afternoon, everyone. I appreciate the fact that this is really sort of like the food coma slash my caffeine, ran out of my bloodstream an hour ago slot. So we'll try and keep this interesting. Before we begin, this has been, by the way, I want to give a big hand, please, to Graham and to the Analytics community. Please give yourselves a hand. This has been a fantastic event. I love how it is a blend of technical and business. So out of curiosity, how many of you, raise your hands, see yourself as a technical user, meaning you write R, Python, or data or process data? Okay, a few of you. So when we get to some of the techniques, I'll be happy to explain at least a little bit about what's going on behind the scenes so that you get some technical value out of it. For everybody else, just check your text messages during those points. This session is being recorded. The video will be available on the aptly named wherecanIgettheslides.com. So in about a day and a half, you'll be able to get the full video and the slides. The reason we're here is because we have been asked by our superiors, by our stakeholders, to deliver three things: better, faster, cheaper. As marketers, and marketers, we're nice people, but we're not especially good at optimizing processes. We've been asked for better, and in fact, instead of getting better, we're getting worse. And the reason for it is that we're being overwhelmed by data. This year, according to IDC, we're going to generate about 30 zettabytes of data as a civilization. Now, out of curiosity, how many people have an idea of how large a zettabyte is? Okay, nobody has any idea. Here's why it's such a ridiculously large number. How many people watch Netflix? Okay, cool, so like everybody. If you look at a Netflix film, about an hour is a gigabyte, give or take. If you started watching Netflix and binge watched, I mean no stopping, binge watched, starting 55 million years ago, in the Eocene era, you would just get through 1 zettabyte today. Right? That's how much a zettabyte is. And we're creating 30 of these. Fun fact, in about 5 years, we're going to be creating about 120 just from our devices. All these little things that we've got connected to us and wires sticking out of us all over and sensors. We're going to be creating a massive amount of data. And the data we're generating isn't necessarily good. How many of you have this person in your CRM? Right? So our data isn't great. So can we deliver on better? Well, our CMOs say no. In fact, the number of CMOs, the percentage of CMOs using marketing analytics for decision making has declined to about 35% year over year. This is from cmosurvey.org, by the way, which, if you have not tried it out, is a fantastic survey of what CMOs think. Basically, they think that we're full of crap. Well, think about it. How much are you spending on analytics, and then to find out that 2/3 of it basically is thrown out the window? We're being asked to go faster. But we're not going faster. Our customers are going faster. In 2017, this is what 60 seconds on the internet looks like. 452,000 tweets, 46,000 posts, 70,000 hours in Netflix. In 2018, 266,000 hours in Netflix. Look at the number of Tinder swipes. 990,000 there, 1.1 million there. I'm guessing mostly left. Those who laughed know why. But this is a tremendous amount of data. So the data is going faster. If you and your company were on the front page of the Wall Street Journal and the New York Times, you today will be one story out of what will be 100 million stories this year. Right? That is a tremendous number of news stories. When people who are graduating this year were born, down here, you're talking like in the 2 to 3 million stories a year in that year of their birth. In perspective, news stories per day, about 200,000. So if you're a front page story, you are one of 200,000. So we're not getting any better at being faster. In fact, we're getting worse at it. The world is getting faster than we can get faster. And of course, the third thing we'll always ask for is, can we make things cheaper? The answer is no. We are spending more as marketers than we ever have. Right? We're spending more on CRM, we're spending more on brand, we're spending more on services. The only thing we're not really doing there is product. But think about just how much it is that we are spending to try and make marketing better. So are we getting to better, faster, cheaper? Nope. So how do we get to better, faster, cheaper? The answer, which is the reason I presume you're sitting in this room, and not because the chairs are comfortable, is artificial intelligence. Specifically, the 3 benefits of artificial intelligence, which are acceleration, accuracy, and automation. Acceleration, we want to make things go faster. We can't go much faster. As people, we really can't. We are terrible at math, especially marketers. Marketers are not known for their mathematical prowess. That's part of the reason they went into marketing. And we certainly have more to do every day that frankly we're not very good at, but we can turn over to machines. So for the business folks, let's set some ground rules about what we're going to call artificial intelligence. When you look at how a human develops, human beings develop along very specific pathways. Harvard calls this sort of the developing child. First you have sensory inputs, then you have language, and then higher cognitive function. Those of you who, like me, are parents of teenagers appreciate the fact that cognitive function drops off right when they hit 13. Our machines are evolving the same way. From algorithms and statistics to machine learning to deep learning to general purpose AI, when the machines realize that in fact we're really good at screwing things up and we probably shouldn't be on this planet. So, all machine learning, all AI begins with math, with statistics and probability. One of the things that is so important, especially for your stakeholders, for the technical folks to hear, is that AI is not magic, it is math. Which means that anything you cannot currently do with math, you cannot do with machine learning. Right? You simply cannot create something out of nothing. Once you understand and have math in place, then we move to algorithms. Algorithms are nothing more than repeatable patterns. Your business uses algorithms every single day. You use algorithms every single day. There's a good chance that, I'm not going to ask you, but you probably put the same article of clothing on every day first, right? Some people put the top on first, other people put the bottom on first, a few weirdos put their socks on first. But the pattern is the same, the algorithm is the same. Now where things go different is that traditionally, when in the past we would create software and the software would create outputs. So when you fire up your word processor or you fire up your Tinder app, you're doing something with a piece of software that pre-exists. Machine learning turns that on its head by saying, let's feed data to a set of very complex algorithms and tell the machine, write the code for yourself. We can't do it, you write your code yourself and let us know how it goes. That's what's so different about machine learning, because the machines can learn from what they're given, they can adapt to massive, fast-moving data sets. So let's say we had a table full of blocks like this. Now this is a pretty easy set of data to characterize, but if we had 1 billion of these, there would be a much harder problem to solve. In machine learning, there's 2 broad categories, supervised learning and unsupervised. Supervised learning is nothing more than telling the machine, hey, look for something. So in this case, we would tell the machine over and over and over again through what's called training data, this is the color red. And eventually it would figure out how to find the color red. The most famous non-marketing example of this is IBM using its Watson service to diagnose, there was a woman in Tokyo who was diagnosed with a form of leukemia, and she wasn't getting better, she wasn't responding to treatment. And what IBM did in partnership with Tokyo University is sequenced her genome and then fed Watson 233,000 oncology journals and studies and said, figure out what's wrong. Supervised learning, figure out what her symptoms actually look like. She was being treated for the wrong kind of cancer. So they changed the treatment and she got better. Now that's pretty cool, but the cooler part is that Watson did it in 11 minutes. The second type of machine learning is called unsupervised learning. It's great to know what the color red looks like. But suppose you had 1 billion of these blocks. How else would you want to sort through them? You could have, I guess, 1 million interns sort them. But the easier way is to have a camera pointed at them and sort by colors, by shapes, by sizes. And that's called unsupervised learning. Just what's in the box of a massive amount of data, categorize, tag, and collect it so that we can analyze it and then make something useful of it. So for example, I was doing a client project recently, and it was 15 minutes before a meeting, and they wanted to know what 2,600 articles about their brand said. So we fed it to what's called a topic modeler. For the technical folks, this was using the Quantata library in R, which is a fantastic library, and spit out one topic model in about 5 minutes. The articles, by the way, all said that the client was an idiot, so that didn't go so well, but we got the answer very, very quickly for them. When you start to glue together all these different techniques, machine learning, supervised and unsupervised, and stack it so that the data flows from one to the next, like pancakes, and where the syrup is moving from one layer to the next, you get to what's called deep learning, where you are creating machines that can do things better, faster, and cheaper than we can, by a significant margin. How many people here use Google Translate? How many people have been using it for at least 2 years? Okay. You know then, about 2 years ago, it got substantially better. And the reason why is that instead of trying to do a one-to-one, so take butterfly and make that equal to mariposa, instead they took all 103 languages they had indexed and told DeepMind, figure out how these languages relate. And through a fairly complex process, what DeepMind found was there's sort of a proto-language underneath all of the human languages. And so now when you ask Google to translate, it goes English to Google to Japanese, or Dutch to Google to Swahili, which also means that if you put sentence fragments in Translate Ilk and tell it to come up with the target language, it can actually assemble a reasonably coherent language. That's the power of deep learning, to be able to solve very, very large data problems. So when we're talking about the universe of AI, these are sort of the hierarchy of how it looks. Now, why do you need to know this, especially if you're a marketer? The reason you need to know this is because an awful lot of vendors like to claim that every single thing, from their toothbrush to their SaaS platform, has AI. So you need something of a fact checker. And knowing how these technologies work and how they map to the different processes in your company is important. If you're familiar with Gartner's hierarchy of analytics from 2011, descriptive, diagnostic, predictive, and prescriptive, when we start looking at the different machine learning technologies and how they apply, it becomes apparent how you should be applying these technologies. Descriptive analytics is the stuff, what happened. And that is all pure quantitative basics. Can you even find your data? By the way, this is where 95% of companies are stuck. Then there's diagnostic. Why did it happen? And that's when you develop your qualitative research capabilities. Then you start moving into the interesting stuff. Predictive, what will happen next? And that's statistical. Prescriptive, what should we do, is where you can use machine learning to solve a lot of those problems. And then proactive, can a machine do it for me? And that's deep learning. There are very, very, very few companies that can do this. About the only one that does it on a regular basis well and impacts your life is Amazon. So let's talk briefly about what problems you can solve with artificial intelligence. In 2010, then Secretary of Defense Donald Rumsfeld was, I suppose, appropriately mocked for giving a briefing talking about the known knowns and the unknown knowns, and no one had any idea what he was talking about. But his matrix is a really good way to approach how AI is useful. When you have known knowns, we know what we know what the problems we're trying to solve, we know what data we have. Artificial intelligence is fantastic for helping us go better, faster, cheaper. When we don't know what we know, which is the case in a lot of companies where you have silos, where data is siloed and blocked, you have these unknown knowns, and that is a governance problem. AI will not fix a governance problem. Technology will never fix a people or process problem. It will just make it worse and more expensive. When you know what you don't know, you have an idea of what you're trying to solve, but you don't have the data. That's a data science problem. That's a problem where you need to do the actual scientific method to resolve those unknowns and turn them into knowns. And then the unknowns, we have no idea what's going on, is actually a good thing, because it's why we all still have jobs. This is where things like domain expertise are so important, because this is where our life experience comes in. And that's really where AI is terrible right now and will be for a while. AI can't do empathy. It can simulate emotions, but machines can't feel. AI is not great at judgment, particularly very complex judgments that can do decisions and probabilities, but not complex judgment like, should you date this person? It can't do multi-domain very well at all. And it can't, for the most part, replace human relationships. The exception is if your customer experience is so terrible that a machine will be better. Is there anyone from the Department of Motor Vehicles here? That is an example where, you know what, I would rather deal with a machine than deal with the surly human behind the counter. So these are the things where AI is not as applicable. So let's look at a few applications. How do we apply this as marketers? 5 major areas. The first is brand, then engagement, conversion, loyalty, and measurement. In brand, artificial intelligence is useful today in assessing where a brand stands. And these are techniques, one of which is called vectorization, where we can take a massive amount of data and say, okay, what are the words and phrases that are most closely mathematically related to a target phrase, like your brand name? This is one I did for a marketing company, and they wanted to know, when people talk about them, what do people most say? They're leading and helping and packaging, understanding, digital marketers, building. If you didn't know this about your brand, this is a very helpful mirror to understand what people actually say about you, which, by the way, most of the time for marketers is very different from what you think your brand is about. For the technically minded, the fast text library from Facebook is a fantastic vectorization library. It is so damn fast. You can reverse engineer Google using a very similar technique. If you were to take the contents of the top 5 or 6 pages for any given set of search terms, search keywords, put them in a database, and run a vectorization library across that, you would be able to figure out what are the terms and phrases that are most common for those keywords across the corpus of text. So you can figure out, okay, if I want to rank #1 for Minneapolis analytics, what do the other top ranking pages all have in common? And you can feature engineer that set as wide as you want it, but at the very basic, just suck in the text, vectorize it, and figure out what do they all have in common. These are the things that I should probably have on my page. The reason is, nobody knows how Google works, including Google. Google uses deep learning. It's a big black box, which means that no one knows what's in the algorithm anymore. All they know is that it kind of, sort of, mostly works. So in order for us to counter that, we have to at least approach it with similar technology. We can do prediction as well to figure out brand. If you were to do a search forecast, this is a search forecast for a bunch of these brands, and take what trends there are existing. You can get 10 years of data out of Google Trends, match it with keyword data. You can forecast forward when will searches for a particular brand spike over the next 52 weeks. For the technically minded, this is Facebook's profit library, which is there's some disagreement about whether ARIMA is technically machine learning or it's just statistics. Either way, it works really well. I tested it last week against a multi-layer perceptron and ELM, and both of them did much worse than Profit did. Profit is really good at understanding seasonality. I think it's how Facebook knows to just keep showing you ads. So imagine being able to forecast, when are people going to search most for my brand in the next 52 weeks? Or for the product category, or for our competitors? How can we use that to time ad budgets, or content, or social media posts, or events? We can use machine learning for engagement. If you go visit the folks up at the Neo4j booth, for example, graphing databases are incredible ways to understand and boil down very complex networks. I was at a conference about a month ago called Marketing Prof's B2B Forum. There were 30,000 posts a day from this conference on social media, and I wanted to know who was most talked about. So did some pre-processing, stuffed it into a graphing database, and asked it, show me who is most talked about. And this just gives me an influencer list of people that I can go and target, or in this case, we were at the event, so just walk over and say hi to them, we know who they are, and get them to talk about us. Because if you've got the people who are most talked about talking about you and your products and services on stage, you'll have a much more successful event. You can use the same technology for any kind of influence where you want to be in front of other people. And you want to identify who is most talked about or who can make the best connections for you within a crowd. When it comes to conversion, again, forecasting is so important, being able to do predictive analytics. Here's a fun one. When are people going to be reading their email the most? When people search for terms like Outlook out of office, or out of office template, or out of office settings, there's a very good chance that in a very short amount of time, they're going on vacation and they don't want to be around reading email. So if you take that, you forecast it forward, and then you invert it. When are people searching for that the least? These are the times of year that when people will be searching for the least. So in the next year, it's going to be second week of January, third week of April, second week of September, fourth week of October. This is when people will be reading their email the most. And therefore, if you are sending out marketing campaign materials, this would be the times to do it. Equally true, don't send it these weeks of each quarter. These are very practical applications of using forecasting and predictive analytics. One of the most important things about AI and machine learning as it applies to marketing is taking away some of the magic and saying, look, all you're doing is planning better. Right? People can wrap their brains around, oh, this helps us plan better. Another example on the conversion front are using chatbots. Everybody and their cousin's using a chatbot of some kind. They're not bad. They're not magic, but they're not bad. And there's something that are definitely worth looking into, particularly from a lot of the CRM vendors, because it's relatively easy to get started. The fourth application is loyalty. I was just in the Polaris presentation. I thought they were very, very, very right in saying that marketing's job does not stop at the purchase. It stops when the customer quits being interested in you. This also applies to employees too. We did a fun thing. We did natural language processing, again, using a combination of Quantata and the UD pipe library in R, of 2,700 Glassdoor reviews of Olive Garden. For those of you who don't know what Olive Garden is, it's sort of a fake Italian restaurant chain. They have a dish that most Americans love called unlimited soup, salad, and breadsticks for $12.99. I think it's $12.99. People love it. Employees hate it. Employees hate it with a passion. In fact, other than things like bad pay and my manager showed up drunk, it happens a lot. The breadsticks are what employees hate the most. Of all the things, the endless breadsticks. You are a breadstick slave. And the reason for this is in 2014, an activist investor firm took over Olive Garden and said, our number one goal is to reduce food waste. Now, they may have succeeded in trimming off, like, I think $60 million a year in food waste. But the question is, how much of that also damages the customer experience, because now the server hates you. The moment you ask for the next basket of breadsticks, the server's just going to start spitting in your food. And finally, of course, measurement. There is no better place to start using AI than in measurement. So attribution analysis, particularly digital attribution analysis, is one of the most powerful, easy ways to show the value of AI. This is taking, we use Markov chains to pull in analytics data, path analysis from Google Analytics, and basically digest down what are the most impactful channels. If you're not familiar with Markov chains, it's kind of like digital Jenga, where you simulate conversions over and over again, and you keep pulling a block out at a time. You do that 100,000 times, and then you figure out this channel causes the tower to fall down the most, which means it's the most important. What's really interesting is that when we did this for a client, they thought Facebook was the thing. But in fact, it actually is not the thing for them. It's Facebook isn't for a little ways down. Twitter was their thing. So they had immediate insight, oh, we should change our strategy. Maybe try that using Twitter more helpfully. Comments on their blog mattered a lot, and they weren't giving it the love that it deserved. So being able to do this attribution analysis is essential. This is, there's actually, for people who use R, there's a channel attribution package in R that lets you plug right in. You have to connect to Google Analytics with the RGA package, but then you can do this. Google charges $30,000 a month for that. So if you can do it yourself, save yourself 30 grand a month. The most important things to start now with this stuff, and the reason for that is machine learning is based on data. The sooner you collect data, the sooner you have data, the sooner you can get modeling, and the sooner you can get that competitive advantage. How do you get started? 7-part journey. You begin at the bottom with that data foundation. Do you even have the stuff? What condition is it in? You're going to spend a lot of time here. Hopefully that you can get out of this phase as quickly as possible. Then you move to measurement analytics. Do you have KPIs? Do you have KPIs that are connected to reality? Are they useful for making data-driven decisions? Build your qualitative capabilities. Be able to tell data stories and do market research effectively. Because no matter how good the machine learning still cannot extract out why something happened. There is no substitute for you asking a customer, hey, why'd you buy that thing? Or why didn't you buy that thing? After that, process automation. Starting to automate the known knowns, finding efficiencies. You might use machine learning, you might not, but just by freeing up as much time as you can will give you the time to build in data science capabilities, to learn how to explore the unknowns. Build your stats and math capabilities, your code and your engineering. That's when you start using machine learning in production, and then put AI first across the enterprise. There's a very common question, which is, as a company, should we buy or should we build? And the answer is maybe. It depends on 3 things. It depends on time, money, and strategy. If you have no time and you want time, and you got lots of money, hire a vendor to do it for you, because you can get up and running faster. If, on the other hand, you don't have a ton of money but you got lots of time, build it in-house. But the really big thing is the strategy. There's this concept right now in the business world that's a little overhyped called digital transformation that promises rainbows and puppies and hugs. The few nerds in the crowd who play Diablo 3 know exactly what this is. But digital transformation fundamentally is about making a company a digital-first company. One of the most important things then is that balance sheet. Let me make that bigger. When you start embarking on your AI journey, you are taking data, you are refining it and cleaning it and building processes around that data, intellectual property, methods, and then you're building models on top of that. Those are things that are assets unto themselves. Those are things that will help transform your company. The most famous example of this is actually not a machine learning example at all. American Airlines in the 80s built a reservation system that was so powerful they licensed it to every other airline. It was called the Sabre booking system. And it was a whole company unto itself. I think it eventually spun off. Think about your company. If you're growing coffee trees, for example, and you collect great data, you can license that data. But then if you build a model on top of that data, you could move that model to, I don't know, corn or soybeans or Spam. The Hormel's in town, I think. You don't really grow Spam, but but it's an important consideration. It's an important strategic consideration. If all you want are the efficiencies, better, faster, cheaper, buy. If you want to transform your organization, you have to build. There's no getting around it. Who do you get it from? I mean, take your pick of the Magi. Microsoft, Amazon, Google, IBM, all of them have great platforms, and those platforms start off free and easy to use and become egregiously expensive before you know it. When it comes to learning the code, the two main choices are R and Python. I am older, I have a lot more gray hair, and so I like R better because I can understand its syntax. I still don't understand Python's indents, but it will depend on who you have in your shop. The best thing that you can do personally is to take something and analyze the crap out of it. So this is a fun one I just did, taking a look at 1.6 million Medium posts, and this was, I think I used XGBoost for this, but I just said, what matters for a Medium post to be successful? And it turns out it just has to be long. Literally nothing else matters, not the topics, not the sentiment, none of that. All that people like on Medium is verbosity. So if you want to market on Medium, just write really long posts. Don't say something in 5 pages you can say in 20. How do you get your company ready for AI? You're going to need 3 kinds of people. There's a great expression, data is the new oil, which is a fantastic expression because crude oil is useless. It's stinky, doesn't really do anything. You need to refine it, extract it, refine it, and deliver it to market. The same thing is true of AI. You need to extract the data, clean it, and then bring it to market. So you need developers, who are the people who can get to the data wherever it lives. As Steve Ballmer was sweating profusely at a Microsoft event and screaming at people. You need data scientists who can refine it and help you build these models. But most critically, the part where many companies go completely wrong is on the marketing technology front. Because companies generate tons of insights that then find their way into binders that stay on shelves and no one ever uses them. So this part, which is, by the way, the part that you probably play the most in your organization, is the most valuable. How do you take those insights and actually put them to use? In terms of your own career, how do you prepare for AI? First, you need multidisciplinary skills. When we look at what's happening, machines can automate the boring stuff in almost any profession, without a doubt. But when you have multiple skills across different domains, different disciplines, it's much, much harder to automate. So if you're good at data presentation and stats and SEO, you are a very difficult person to replace. So if you're not a developer, you're not a coder, you're not a data scientist, at the very least, look at building extra domain expertise into the work that you already do. Learn to think like a machine. Every time you face a problem at work, are you thinking, do I solve this problem, or do I build a process that solves this problem perpetually? That type of thinking is very, very powerful thinking. Learn to oversee the machines. One of the biggest problems we have in machine learning right now is bias. Our algorithms are biased, our data is biased. We were having a conversation last night at the reception about one of the contests that MinneAnalytics did. People using social media data to try and predict the election in Minnesota. Well, if you don't know that on Twitter, for example, it skews Democratic, skews younger, skews minority, skews lower income, you're building a model that's biased. So being able to oversee the machines is super important. This comes to life in a whole bunch of really frightening ways. In 2016, police department in Atlanta attempted to predict Who would reoffend? They built a machine learning model that would predict reoffense by criminals. The model was 20% right. You would have been better off flipping a coin. But it flagged African Americans as 5 times more likely to reoffend than they actually did. Someone put their thumb on the scale and made the model perform badly. More recently, Amazon had to throw out its AI-based hiring system because it turns out that when you spend 10 years hiring nothing but guys, the model is going to predict you should hire more guys. We know that's not the outcome we want. So being able to supervise machines and say, nope, that output is not okay. This is especially true if you're in a highly regulated industry, because if there are certain criteria, certain features you are not permitted to use for decisions, you also have to look out for inferred combinations. If I say gender's not allowed, but I use movies, books, and music that you like, I can nail gender about 99.9% of the time. Right? So you have to be able to supervise machines and say, no, the XSplit will follow the letter of law, but will also follow the intent as well. Be outcome focused. For those of you who are on the coding side, you probably know this chart. I was trying my hardest to learn how to use Keras and TensorFlow. I got to about here in 12 months of reading and researching and testing out code. And then I went to IBM Think this year, and they said, oh, we made that drag and drop. Thank you. But instead of having to write the code, now all I have to do is know what the pieces do and know the logical sequence and the strategy for deploying them. I don't have to worry about, like, did I screw up my Python code and put 4 spaces instead of a tab in it? The tools are getting easier to use. I was doing something this past weekend. I was using the visual recognition system to look at solar panels. I flew a little drone over my house and I said, hey, learn what solar panels look like. And then I took a bunch of other photos and I fed it in and said, score it. And it said, okay, so ice cream, pretty clearly not solar panels. This room for voting, not solar panels. My dog with a hat, not solar panels. But a photo that's very different than this one, yes, solar panels. 0 lines of code. Right? So as marketers, we will have the ability to start using these tools without needing to be coders as long as we understand what the tools do. In the future, well, actually it's not even the future, but it mostly is, there's going to be 2 kinds of jobs. Either you're going to manage the machines or the machines are going to manage you. When I was at the supermarket recently, I saw a guy pushing the maintenance cart, and he had the mop and stuff like that, and he had one of those hand scanners that you normally use for like shopping to do self-checkout. He gets to the top of the aisle, zaps the aisle, walks down the aisle, picks up some random stuff or whatever, and goes to the other end of the aisle, scans the top of the aisle. I'm like, what is he doing? Then I realized he's being managed by a machine. They are measuring how long it takes him to get down the aisle. If he goes too fast, he's not doing his job. If he goes too slow, he's not doing his job. He's already being managed by a machine. You are too. Out of curiosity, how many people check their mobile phone in the first hour of the day? Is there anybody who didn't? Right? We are all being managed by machines. The question is how conscious are we of that? How much of a conscious choice is it? So, with that, thank you very much for your attention. I think we have about 10 minutes to take questions, give or take. Anyone have any questions? Sure. Actually, this person with the microphone is going to run up here, so I'm going to run up here.
Hi. In general, do you think that if the tools become too easy, we are going to learn to take shortcuts, or do you think people should skip the shortcuts, learn how to do it themselves the hard way once? Where's your stance on that?
I believe there is still value in at least having the experience, just as there's still value in teaching your kids how to do multiplication and division the long way, and then you can introduce them to the wonders of a calculator. But knowing the mechanics is important. Like, for example, when you're doing text mining, knowing how vectorization works is a good thing to know, because that will help you understand the biases. Because there's broadly four types of bias in machine learning data, right? There is intentional, like, hey, I want this to say a certain result. There is target bias, where the population that you're analyzing has, the data itself is corrupted. So African American healthcare data, there is zero useful healthcare data for African Americans in the world, none. Because there's such a systemic bias against African Americans that the healthcare data is all wrong. You have to actually build models from scratch. There's source bias, which is where the data itself is not correct. That's like, for example, using Twitter to try and predict an election. And then there's tool bias. There are limits to what the tools can do, and that's where learning to do it the hard way can come in handy. There's a whole bunch of folks in the social media marketing space who are trying to build all these social analytics tools, and I saw one that was really terrible. It's like, hey, we can predict, Instagram things, but they were predicting the text on Instagram. Now, how many of you have this friend who's like, hey, they post a picture, and it's them on a beach in various states of undress, and there's a beverage, and you get the idea. And then the caption is, well, this sucks. Now, we all know what that means, right? This is pure sarcasm. But the software doesn't understand that. The software thinks that's a negative post, right? So being able to do it the hard way and understand what goes into the algorithm is important for being able to fact check them. Mm-hmm.
So maybe it's not a question, but an observation, maybe you want to comment on it. So back several slides, I think you were kind of looking at attribution of various channels.
Yes.
To whatever. So myself as a marketing agency owner, over the years, many times having conversations with brand managers or the stakeholders of a brand, without first looking at the data and getting those insights. What I hear most of them saying, I just want to turn off blog comments because I don't want to devote any time to it, or I don't want to manage it. But in that situation, that was a major contributor
Yes.
to their conversion or whatever it would be. So
Yes.
what's your comment as far as looking at that? Maybe it's an obvious thing, but just look at your data first before you just jump into making those conclusions.
It's one of the hardest things to do is to try and encourage somebody who is not data-driven to change their decision-making process to being data-driven, and that's still going to be a human thing. If you know that person is motivated by greed, then you can say, hey, this is going to make you a lot more money. If you know that person is motivated by fear, like, hey, if you don't want to get fired next quarter for another quarter of shitty results, you need to do it this way. But whatever it is that makes that person tick, that's how you have to approach that person. There's what, 4 fundamental ways to motivate somebody. There's fear, greed, sex, and anger, and that's about it. So figuring out what it is that makes them tick, and then appealing to that within the limits of ethics is how you get around that. But it is very difficult to convince somebody with the data alone to make a change in decision. You have to convince them that the outcome is something they either want or they're afraid of. Other questions? Over there.
What, according to you, is the major challenge in terms of technical standpoint for personalized marketing? Like, marketing has evolved from targeting a group of people. Right now, it is trying to target individuals, right? So, what are the technical challenges you're facing?
The number one challenge that marketers are going to face in the next 2 to 5 years is their over-reliance on personally identifiable information. Right? We saw a lot of this past year with GDPR. Everyone and their cousin got it. Hey, we're updating our privacy policy email in May, right? Your inbox filled up with companies you've never heard of. Like, I think I might have done this with you once 10 years ago. But PII is going away at some point, or at the very least is becoming extremely regulated, and for good reason. The major tech companies have proven that for the most part, they're completely irresponsible with our data. I'll refrain from Marriott. And so we have to pivot to things that are non-PI but behavioral in nature. Hey, how long did you spend on this site? What things did you click on? Where did you come from? Where are you going? And what can we infer that's behavioral? I don't care who you are. I don't care what color your skin is. I don't care how many kids you have. I do care if you browse the services page, the team page, the about page, and the contact page, because you're probably going to buy something. Most systems and most analytics are not set up for that. Most systems and analytics are still looking for someone to fill out a form and say, okay, now based on the domain name of your email address, you're probably this kind of buyer, which is a really bad decision to make. But that it is a big technical challenge, and it is a big strategic challenge to get people to be thinking anonymized behaviorally.
Thank you, Lord. That helps.
Mm-hmm. Other questions? Going once, going twice. Thank you very much.
Want help solving your company's data, analytics, and digital marketing problems? Visit trustinsights.ai today and let us know how we can help you.